Today class is about the Maxwell equations, and as you know that the light wave is electromagnetic waves, and Maxwell derives the four equation for the electromagnetic waves. And hope you have studied this Maxwell equation in your previous course, electromagnetic field theory. So here we will use the phasor form and instantaneous form of the Maxwell equation, and then we will study the propagation of the TM waves in lossless dielectric medium. So as the light is transverse electromagnetic waves, and we will define here, so what will be the behavior of the light when it is blue in lossless medium? And coming lecture we will study the propagation of these waves in lossy medium. And here we will study that what is meant by lossless and what is meant by lossy, and is this is practically exist or not. These two lectures are equation based, and we will derive some equation here, and other of them they are mostly theoretical. So let's consider the table number 1, which show the corresponding phasor value of different electrical quantities. In table number 1 there are two types of quantities. One is the instantaneous value and other is the phasor value. In standard books, by standard book we mean that the book of optical fiber communication, which is our core book, they follow some notation for phasors. So when they want to show the phasor value, for example this is the electric field intensity, so they will write arrow in such form above it. So this is the standard notation of the phasor wave. So the electric field intensity, it is denoted by E in instantaneous form, and it is denoted by E with arrow in phasor form. And you know what is meant by instantaneous value, and you know what is phasor value. If you have forgot, so you can read it. And this is your reading assignment that you study the Maxwell equation of your previous electromagnetic field theory course. Here we will use this equation, and then we will convert this equation into phasor form, and by using the Maxwell 4 equation we will derive the wave equation for the light wave in lossless medium. So these are some notations that we have already studied in the electromagnetic field theory. So please study these quantities, and that you are able to define that what is electric field intensity, what is electric flux density, what is magnetic field intensity, what is magnetic flux density, and conduction current density. For definition point of view, you can review your previous course. Here we will study these quantities. So I'm not to explain that what is electric field intensity as you have studied in more courses. So the electric field intensity, it is denoted by E, and it is the instantaneous wave. If you want to write this in the phasor form, so we will write the arrow above it. It will look like this. This is the phasor form, and the most of the standard books follow this notation. B mean the electric flux density, and this is the phasor representation of the electric flux density. And you also know the relation between the D and E. The density is the epsilon time of electric field intensity. H show the magnetic field intensity, and H above arrow show the magnetic flux, magnetic field intensity in phasor form. B show the magnetic field intensity density, and the arrow with the B with arrow show the phasor form. And this is a relation between the B and H. You may know that this is the mu naught time of H. And what is mu naught? What is mu? Mu is known as permeability. This epsilon is called permittivity, and this mu is called permeability. So the D is equal to epsilon E, and P is equal to mu. It is mu H. And J is the conduction current density. So here we study the some instantaneous and some and its phasor form. In order, if you want to convert the Maxwell equation from instantaneous form to phasor form, so we will follow two steps. In step number one, we will write the instantaneous, every instantaneous value in with corresponding phasor value, and for this we will use the table number 1. The second, we will replace curly by curly t by j omega. When you want to convert the instantaneous form of Maxwell equation to phasor form, so we need two steps to replace the instantaneous value of electrical quantity into phasor form by using given table 1, and curly by curly t by j omega. These are the two steps. When you want to convert the four equation of the Maxwell from instantaneous form to phasor form, so we will follow these two steps. For example, the first equation of the Maxwell is given by this equation, and you can state this equation that the gradient of the ये आपके साथ एक ऑपरेटर है and this is dot. So when this operator is in dot, so we say that the gradient of the electric flux density is equal to volume charge density. The Maxwell first equation says that the gradient of electric flux density is equal to the volume charge density, and this is the volume, rho v is the volume charge density. And you know that what is volume charge density? It is the charge per unit volume. For example, this is a volume and this is unit volume. So how many charge are here? So charge per unit volume is called volume charge density. So let's convert this equation into phasor form. So the first step is that we will write this instantaneous wave into phasor form. So the gradient of the flux density in phasor form is equal to rho v. So this is the required phasor form representation. This is in instantaneous form, and this is the first equation in phasor form. And this equation states that the gradient of the flux density, electric flux density, is equal to volume charge density. Consider the second equation. The gradient of the magnetic flux density is equal to 0. So when we convert this into phasor form, so we will write this B in phasor form. So gradient of the phasor form of B is equal to 0. This is second equation. And you may know the third equation of the Maxwell is, this is cross. So this cross is called current. The other is called gradient, and this is called current. Current. The curl of magnetic field intensity is equal to the conduction charge density plus the curly by curly of electric field density. So when we convert this equation into phasor form, so we will follow the two steps. The first step, we will write this into phasor form. So the H is here in instantaneous form, and here this H is in phasor form, is equal to, we will write the J in phasor form plus, we will write curly by curly, partial by partial by J omega. So J omega D, in D को ऊपर रखिए इस तरह arrow. So it means that we have convert this equation from instantaneous to phasor form. The fourth and the last equation of the Maxwell is that the curly of the electric field intensity E is equal to minus time of curly by curly B. And what is B? B is the magnetic field uh, density. And this equation shows that the change in the magnetic field will produce electric field, and the change in electric field produce varying magnetic field. The varying magnetic field produce electric field, and the varying electric field produce the varying magnetic field. So the phasor form of this equation is curl of the E, and this E is in phasor form, is equal to minus, we will write J by partial T by J omega, and we will write the B in phasor form. So this equation shows the phasor form. So there are four equations, and we write these four equations in phasor form. The first equation was that the gradient of the D is equal to volume charge density, and this is in phasor form. This is the second equation, that the gradient of the magnetic field B is equal to 0. So this is in phasor form. This is the third equation, and this is the fourth equation. These are the four equations of the Maxwell, and we have write these into different form: the instantaneous form and the phasor form. So let's start the propagation of the light wave in lossless medium. So as you know that the light wave is the electromagnetic waves. and these electromagnetic हाँ सादा
सर ये इंस्टेंटेनियस से हम फेजर फॉर्म में क्यों कन्वर्ट करते हैं, मतलब ये हम किस लिए यूज करते हैं फेजर फॉर्म?
because in the phasor form uh, it show the specific direction. So when we want to study the light wave, that in which direction they are propagate, and in which direction it has magnetic field, in which direction they have electric field. So for this we will use the phasor form. As you know that the phasors have a specific uh, direction, but you know that the electric quantity have their scalar quantity, and we can represent the scalar quantities in the form of the phasors. For example, if you have studied the phasor form of the coil inductor, so you say that if this is the current I and this is the uh, voltage, so they are leg and they are leads with angle of 90. So for this you will use phasors. So phasor is the vectorial representation of the electrical quantities, and these electrical quantities are generally scalar. But when we represent this in phasor, so it will behave like a vector. They are not vector; they behave like a vector. So the vectorial form is called phasor, and we can study easily its behave through phasors. So that is why we convert here into phasor form. So the propagation of the TM wave, so we studied that the light waves are the electromagnetic waves. And these electromagnetic waves contain two fields. One is E field and one is H field. And if you know, I have shown the light waveform. Light wave. This is the light wave. So you know that if consider this is the, if we consider this is the z direction, consider this is z, and this is the x, and this is the y. So if the light waves is flowing in the direction of z, and suppose its electric field intensity direction is along x, so then the magnetic field will be along the y. So you know that these three are perpendicular to each other. So this is why they are called transverse electromagnetic waves. So transverse से हमने लिया T electromagnetic waves to TEM, transverse electromagnetic, and you know that what is transverse wave? When the E field and H field are perpendicular to each other and they is perpendicular to the propagation direction. So this is called transverse wave. And you also define simply that when the vibration of the mediums, if they are dependent on the mediums, so electromagnetic waves does not depend on medium. So in the case of electromagnetic waves, we say that what is the transverse wave? Those waves in which the E and H field are perpendicular to each other and there is perpendicular propagation direction. And those which depends on the medium, for example, sound waves are the string waves. If consider this is a string, and when we shake this, so it will behave like this. So here the waves flow in this, move in this direction, and this particle either can move upward, either and downward. So they make 90 angles with each other. This is called transverse. And if you consider these spring waves, when we attract the spring, so the wave will be flow in this direction, and this particle also vibrate in this direction. They are make zero angle with each other, so they are called one is transverse and one is called longitudinal waves. So these are longitudinal waves. So here from this figure I want to explain that the light signal is TEM signal. This is the transverse, and the light is electromagnetic signal, and this is transverse. So this is the transverse electromagnetic wave. And so how this the light travel in the lossless medium. So here we will explain. This topic show the derivation of the this topic show the derivation for the wave equation in the lossless dielectric medium. If someone asks they derive the wave equation for the transverse electromagnetic wave in lossless medium, so we will follow this topic. So what is meant by transverse? So transverse electromagnetic waves are also known as uniform plane wave. As discussed in the preceding section, electric field intensity and the magnetic field intensity and the velocity of transverse electromagnetic wave are normal to each other. जैसे कि अभी मैंने आपको बता दिया कि in the picture you see that the electric field and the magnetic field and the propagation direction are normal to each other. By normal mean they make 90 angle with each other. So this type of wave is called TEM waves, and the light is the TEM waves as, uh, as shown in the figure 1. This is our figure 1. So consider the velocity is in z direction and the electric field in along the x direction and the magnetic field is along the y direction. And here it will behave like this. This is the direction, this is the one quantity, and this is the other quantity. And you know that they make 90 angle with each other. They are perpendicular, they are perpendicular, they are perpendicular. And what is mean by the lossless medium? The lossless medium is the ideal medium, and the attenuation of the signal does not take place in this medium. And practically this medium doesn't exist. And you know that we study firstly ideal form, and then we were entering to the real form. So today we will study the ideal portion, that if they are flowing in lossless medium, and by lossless medium mean that the signal does not attenuate in this medium. So theoretically it doesn't exist. And you know that why we study then, so it will be basic for the practical medium, for the lossy medium. So if we study the ideal uh, if we study the propagation of the light wave in lossless medium, so then we can easily understand the propagation of the light wave in lossy medium. And the lossy medium and this medium in which the attenuation of signal will be take place, and they are the practical medium. For example, it can be wireless uh, for the wireless communication, and for the optical fiber communication, the optical fibers made of glass and plastic are the lossy medium. So if there doesn't attenuate the signal, it means that the conductivity sigma of the medium is zero. There will be no conduction current. So consider this figure. Consider the velocity of the light in this direction and positive z-axis. ये याद रखिए, when we derive the equation, so we will neglect some quantity because here we consider that our light signal is only flow in positive direction, and this is AZ. And what is meant by AZ? AZ is the, do you know AX, AY, and AG? Do you know what are these? AX, AY, and AG. Are you hear me?
Yes, sir.
Do you know unit vector? Unit vector.
सर पढ़ा है लेकिन अभी याद नहीं है.
Okay. So the AX and the AY and the AG are the unit vector along the AX is the unit vector along the x-axis, and AY is the unit vector along the y-axis, and AZ is the unit vector along the z direction. And this is called the unit vector in rectangular coordinates. These are called rectangular coordinates. So here we say that suppose the light is the light is velocity of the light wave is only the z direction, positive z direction, and its magnetic field along the y direction, and its electric field is along the x direction. So in order to find out the electric field intensity of the TM waves, we consider the following Maxwell equation in phasor form. That the curl of the electric field intensity E is equal to minus j omega b. This was the equation when here we derived it. The curl of the electric field intensity E is equal to minus j omega, the phasor form of the magnetic flux density B. This is electric field intensity, this is the magnetic field. So consider the curl of the electric field intensity E is equal to minus j omega b. And you know that the relation between the magnetic flux density B and the magnetic field intensity H is that B is equal to mu naught time of the H, and mu is the permeability of the medium. So if we replace B by mu H, so the equation will become the curl of the phasor value of electric field intensity E is equal to minus j omega and mu H. And here you will write this here. So this is our equation 1. So if we take curl of the equation 1 both sides, so then the curl of the electric field intensity E is equal to, these are the constants. So minus j omega mu is the constant, and we will take the curl of the electric field H. Electric field H. And you know this from the another Maxwell equation, which we have derived earlier. That what is the curl of the H? You know here. The curl of the H is j omega plus sorry, J plus J omega d. This J is the current density and this J is the phasor. So if we write this quantity, so curl of the curl H is equal to minus J omega mu curl of the H, and you know that the curl of the H is J plus this, but remember that you will do this phasor symbol. So the curl of the H is this. So write the replace the curl by H by its value J plus J omega W. So therefore the curl of E is equal to minus J omega mu into, write the curl by H by this. So J plus J omega W. And you know the two relation from the EMF course, that D is equal to epsilon naught E and J is equal to sigma E. These are some equation that B is equal to mu H. Remember these three equations, that B is equal to mu naught time of H, D is equal to epsilon naught time of E, and J is equal to sigma naught time of E. So when we write minus J omega mu, so we will replace the J by sigma E and J omega and this D by epsilon E. So minus J omega mu, we replace J by sigma electric field intensity E plus J omega epsilon E. But you know that is, now we want to derive the equation for the lossless medium, and for lossless medium the sigma conduction is 0. So write this quantity by 0. Then you will get only this portion. Curly by curly E is equal to, this is 0 minus multiplied by plus minus J multiplied by J is J square, and omega multiplied by omega is omega square, mu epsilon naught mu epsilon into E. And you know that what is the J from circuit point of view, and this is minus 1, it is behave like iota. So J square is equal to minus 1 is like iota is minus 1. This is complex way. So if we write the J by minus 1, so minus minus become plus, so it will become omega square mu epsilon E. This is our next second equation, that the double curl of the E is equal to omega square mu E and H. Sorry, omega square mu epsilon and the electric field intensity E. Here the curly by curly E is this. Now you know these are the sub quantities that from EMF point of view. So in EMF we study that the curl of the E is equal to minus curl square E. ठीक है, ये हमारे साथ एक ऑपरेटर है, ठीक है, इस ऑपरेटर का स्क्वायर ई के बराबर. एंड व्हाट इज दिस ऑपरेटर, इसका भी इधर हम डिफाइन करेंगे, ठीक है. सो ईएमएफ पॉइंट ऑफ व्यू से हमें मालूम है कि अगर आप किसी का डबल कर्व लेना चाहते हो तो आप क्या करें, इसके साथ स्क्वायर वाली ये जो डेल ऑपरेटर है इसको क्या करें, मल्टीप्लाई करें. मल्टीप्लाई द डेल ऑपरेटर स्क्वायर विद दैट क्वांटिटी. एंड व्हाट इज द डेल ऑपरेटर, this is the del operator that when you take the del square of the E, it means that partial square by partial x square of the E, partial square by partial y square of the E, partial square by partial z square of the E, if this is in rectangular coordinates. So here, if we replace this quantity, if we replace this quantity by this, so it will give us the partial square E is equal to omega square mu E and E. When we move this quantity here, so it will become plus. So let's see here that minus partial square E is equal to plus omega square mu epsilon E square. If we shift here, so del square E plus omega square mu epsilon E is equal to 0. This is the wave equation. This is the wave equation in lossless dielectric medium. But you know that in this equation, and you know that the TM wave is traveling along the fast to z direction in figure number 1. So the energy of the wave will change with respect to z, and z is the distance traveled by the wave. So you know that the electro in figure 1 is discussed in the start of the start of the class. आपका आवाज clear है? ठीक है. So in the start of the class, we studied that consider the electromagnetic waves as flowing, is moving, is traveling the distance along the z direction. So it means that the electric field intensity can be changed only in z direction. So it means that the electric field intensity will be the function of the z. By the function of the z, we mean that the changes in the electric field intensity will be occur only due to z. There will be no changes along the x direction and along the y direction. So it means that if there is no changes in the x direction, so this quantity will be 0 because there is no variation, and this shows the variation. And there is no variation along the y, so this is the 0. So the del square E will be equal to the partial square by partial z square of the E, and these two quantity will become deleted, ignored. So if we replace the wave equation here, so we can replace this quantity by what? By partial square E by partial z square plus omega mu and epsilon E. You know that this is the same value, omega square mu Ez, and we replace just this quantity by what? By partial square by partial z square E. Why? Because you know that the electromagnetic waves in our case that we are discussing here, that the electric field is the waves are only moving in z direction, so there will be attenuation just in z direction, or the no attenuation, there will be a variation in the electric field only in z direction. So partial by partial x and partial by partial y are constant. uh, the, the e and along x and the y are constant, so the partial square by partial x square and partial square by partial y square of the e will be 0 because the derivative of the constant function is 0, you know. So the partial square E and partial Z square plus omega square mu epsilon E is equal to 0. this is the wave equation. But when we see this wave equation is the differential equation. And you have studied the mathematics courses differential equations in your previous classes. That what is differential equation and how we will solve the differential equation. And as this order is 2, so this is the second order homogeneous differential equation. In order to find its solution, we need to find the characteristic or auxiliary equations. So when you want to solve this equation, we will convert this into characteristic or auxiliary equation. So how we will convert? We will convert by simple rules that replace the partial by partial z by m. जो partial by partial z है इसको m से replace करें. Replace partial by partial z by m. So partial square by partial z square is equal to m square. So here we mean that m square e is equal to omega square mu e and e. If we take the e common, so this is equal to m square plus omega square mu e into electric field intensity. And you know that the E does not zero. Why? Because the electromagnetic waves are flowing in z direction. If the E becomes zero, it means there is no wave. So the E does not become zero. It means this portion can be zero. This portion can be zero. So we replace m square plus omega square mu is equal to zero. So if we move this quantity into here, so there this is a plus, so here there will be minus, so it will become omega m square is equal to minus omega square mu e. If you want to calculate the m, so we will take the integral both sides. And you know that when there is a minus value and under the root, so this is minus, this is j, complex variable. So m is equal to प्लस माइनस ओमेगा स्क्वायर से आ जाएगा बाय ओमेगा, और ये जो दो क्वांटिटी है दे can't be from the square root. So we will get this equation here. That m is equal to plus minus j omega mu epsilon. But if you want to study this in wireless communication, so we consider the wireless communication book consider this beta. And if you want to study this in optical fiber communication system, we follow the book fiber optics communication. So in fiber optics communication, it is denoted by K. But let's see here, is this is a complex value. So even this is a complex value, so there are two real portion and imaginary portion. So m is equal to plus minus alpha plus j omega b. Here you know that this is only j omega, it means the alpha is 0. So the beta is equal to this, and beta is already complex j. So beta is equal to omega mu epsilon. But here we will say that this is not beta, this is the k. We will say this is the k. That jk is equal to j omega b and k is equal to omega d. And this is called propagation constant. K is called propagation constant. So the solution of the second order homogeneous differential equation is, so beta is equal to k. It means that there are two roots, one is plus, one is minus. So m1 is plus jk and m2 is minus jk. And what is k? Plus j omega under root j omega under root mu epsilon naught and minus j omega. So if we, m1 is this and m2 is this. So the solution of the differential equation is that the E will be is equal to ये जो मैं अभी कह रहा हूँ ये portion, this is from mathematics. This is not a technical quantity. I am writing this from the mathematics rules, which is the how you will solve the differential equation. So if there are differential equation and you solve, so you will calculate the characteristic equation, and then from the characteristic equation you will write the solution in three different form. So one is E naught e power kg, and one is don't know E naught e power kg something k plus E naught इस तरह कुछ है और एक इसका इस तरह है. वो डिपेंड करता है कि आपकी m किस क्वांटिटी का है. ठीक है. So here the solution is E naught e power minus m1z. If we write the standard form, so the standard form is here, that E will be equal to E1 e power minus m1 z plus E2 e power minus m2z. So write the m1 value. So E naught mean in forward direction, e power, what is m1? Plus jk, so minus jkz, and plus e2 mean in backward direction, eb e power minus m2, so minus and minus jk, minus minus become plus jkz. And as you know that the electric field is along the x direction, and our first figure you see here, this is our first figure. In first figure we say that the electric field is along x direction. So that is why we write here that E naught e power minus jkz plus eb e power jkz is along the x direction. This is the final solution, but in this final solution we want to ignore some quantity. As we discussed that the electromagnetic waves only flow in forward direction, there is a no value in backward direction. And you know that from antenna point of view, that we want to eliminate the reflection. So this is he will use the S parameters. So we consider that there is no reflection flowing in backward direction. So if there is a no value in backward direction, so it becomes 0. And you know in our figure, we have not discussed any value in backward direction. There is only in forward direction. So we can write this equation is equal to E naught e power minus jkz and 2x. This is the equation of the wave in phasor form. If we convert this into instantaneous form, so for instantaneous point of view, you will write that is equal to E naught sine omega t minus kz along x-axis. And how we will convert this? So in previous courses, maybe we have studied that, for example, to the electrical students which are in second semester, sorry, in sixth semester, I have taught a course of AC circuit analysis, And here we study that how we will convert this form into this sine form. And you may also study the signaling system, that in a signaling system when we this is called Euler form and this is called sinusoidal form. So how we will convert to this? So this is very simple rule that write this is E naught sine omega t and write this. Do not write the j. We will write j in just in phasor form. Sine omega t minus k. So this is the final solution, that the E is equal to E naught sine omega t minus kz. Here k show the propagation constant. And this equation show that when the waves propagate along x direction, so in z direction, and then the electric field is along x direction, so the equation of the electric field along x direction will be like this. So this is all about today class. In today class we derive the wave equation for the electric field and and when you know, if you know the value of the E, if you know the value of the E, value of the E, if you know the value of the E, so you can calculate the value of the H from this equation. We have derived the equation of the E and does not derive the equation of the H. And you know that the electromagnetic waves contain two components, E field and H field. So if you derive the E field, so we don't need to derive the H field by applying heavy mathematics like electric. So when you calculate the H field, so you can use this equation, because you know that D is the epsilon E and here the J is 0. So you can calculate by this equation. So therefore, in by using the Maxwell equation, when we have one quantity, so there is no tension that how will be the H. If we know the H, what will be the E? So therefore, here I have derived only the value of the E, and you can calculate the H by the above equation.